All right, so this is a multi-step problem, but really what this question is asking is what is the percent yield of the reaction? Percent yield is equal to actual divided by theoretical times 100. So let's start with actual. What is actually obtained in the lab? That information is given to us here about our product. We're told that we make 4.9 molar sulfuric acid, and it has a volume of 20.1 milliliters. We can use our equation for molarity to solve for moles, right? We can rearrange. Molarity times liters gives us our number of moles. So here, 4.9 times, this number needs to be in liters, so 0.0201, gives us this amount in moles, 0.09849. This is what was actually obtained in the lab. So when we go to solve for percent yield, we're going to have this number on the top. Okay, theoretical yield is really a stoichiometry problem. We are given information about both of our reactants. We're given an amount in grams of our first reactant, and then we're given an amount in milliliters of our second reactant. But because water has a density of 1, which it reminds us of here, because water has a density of 1, so let me change colors here actually. So again, we're talking about theoretical. This has to be solved using stoichiometry. It's actually a limiting reactant problem since it gives us information about both reactants. Okay, so again, right here, 10 milliliters of water. Because water has a density of 1, that's the same thing as saying we used 10 grams of water. Okay, so we know that we started with 40.1 grams here and 10 grams here. Okay, so I'm going to switch over here since this is going to be multiple steps. So for a limiting reactant problem, you need to set up stoichiometry conversions for both of your reactants. Start with the sulfur trioxide first. Okay, 40.1 grams of sulfur trioxide is used. We can go from grams of this to moles of this using the molar mass, right? 1 sulfur, 3 oxygens, 80.06 grams. Okay, 1 mole of SO3, this is our coefficients from the balance equation. 1 mole here produces 1 mole here. So again, just assuming that you know what I mean by limiting reactant problem. But we're going to multiply our top numbers, divide by our bottom numbers. This gives us 0.501 moles of sulfuric acid. Okay, for our water, we're starting with 10 grams of water. Water has a molar mass of 18.02 grams. Again, it's still a 1-to-1 mole ratio. 1 mole of water produces 1 mole of sulfuric acid. And this gives us 0.555. So again, limiting reactant problem, we're comparing these two amounts. Which one is smaller? This one is smaller. So this tells us our theoretical yield. It also tells us that SO3 is our limiting reactant. Okay, so I'm going to go back over this number in green. This is our theoretical yield, 0.501. So what we're saying is under perfect conditions, this is the amount we would have formed in the lab. In reality, we really formed this number, right? So your top number is always going to be smaller than your bottom number. And then we're going to take that, multiply by 100 to change to a percentage. When we do that, we get a final answer of 19.66%. This is our final answer. This is our percent yield for this reaction.